Hello, बच्चों. Once please tell me that if my voice is clear to all of you. मेरी आवाज़ सबको क्लियर आ रही है? Hello. Tell me in the comment section if my voice is clear to all of you. Tell me in the comment section if my voice is clear to all of you. Okay. It is nice. So we are good to go. There were some technical issues. That's why there is some delay. But now we are good to. That's why there is some delay. But now we are. Okay. So fine. Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that all of you are doing very good. Okay. And how your studies are going on? It's your board time. So what about the preparation? Okay. I hope that it is going in correct direction. Okay. Because it is very cold. That's why I wear this blazer. Okay. It's not my natural thing that I wear this. But it's so cold. That's why I had to. Anyways. So we are going to enter into the massive portion of class 12, one of the most interesting portion of class 12 and one of my favorites of class 12, that is optics. Why I'm saying like that? Reason is there. You can visualize everything. The light that is coming, you are going to study that light. The images that you watch in the mirrors, in the lens, reflection, lot of practical phenomena are there. That is what we are going to understand. Very less number of formulas are there. You just have to understand how to apply the formula. If you are talking about J advanced, then there is a separate thing. For J advanced, of course, it's a very applicable thing. Okay, but for JEE mains and the NEET or board level, anyways, you have to understand the derivations part majorly. Okay, so if you are leaving this portion, this chapter is very interesting. Okay, so we'll be watching that in complete depth. Every single thing will be starting from reflection from plane and spherical surface. Then we'll be entering into refraction also, reflection from plane surface, slab, prism, all these things, TIR, and all these things we are going to understand and complete that. Then we'll be watching the refraction through the spherical surfaces. Then we'll be watching about reflection from the lenses. Lenses are also made up of two spherical surfaces. Some of the basic things that you already know in this chapter. What is the basic thing? Mirror formula, all of you know what is mirror formula. 1 by v plus 1 by u is equals to 1 by f. All these terms, v, u, f, what are these terms? Again we are going to see. Anyways, I think that the students study decent amount of about these optics things in the class 9th, I guess, if I'm not wrong. Okay, class 9th. Okay, so fine. So we are very good to start now. So let's begin the topic without wasting any further time. Okay, be ready with your pen and paper and be excited to learn something new, very interesting. This chapter is, it will never feel you boring. Okay, this is completely excitement. And the first topic that we are going to understand is plane surfaces. Plane mirror is what we are going to understand, and a lot of properties that you would be already knowing about it, and some more important things that I will be telling to you. Okay, all these things we are going to see. Okay, very good. So let's begin. Optics. See, optics is the study of behavior of light. Okay, behavior of light. And then there was a very big debate also, that light is wave nature or particle nature. I will tell you a story when we are going to start wave optics. Light is also distributed into, optics is distributed into two sections. One is geometrical optics or ray optics we used to say, and then we study about wave optics. Wave optics is the next chapter that we are going to. Then I will tell you a story. What was the complete background of this starting of the debate of why light nature and particle nature? Tell me, light is what? Wave nature or particle nature? Comment down in the comment section. And as we'll discuss about this also, reason is also there. Why we call this, what we take, light take, wave take, or the combination we used to take, and why we take. All these things we are going to understand. So first of the portion, we are going to understand only about geometrical optics, or also I can call it as ray optics. Okay, fine. So let's begin our chapter. So firstly, let's understand how we are able to watch anything. Okay, how we are able to perceive anything. If I am watching this pen, how I am able to watch this pen? What is the actual phenomena is happening behind this? So actually, if I will tell you what is happening, some light sources are there in this room. Okay, a lot of light sources are in this room. From that source, a light is coming to it. Light rays are coming. Light rays are represented from straight lines, you already know, in form of array. Okay, so light ray is coming here, and what is happening, some portion of that light will be reflecting. It will be reflecting all the direction. Some portion of light that is reflected, it is now coming to my eyes. Some portion that is reflected from here is coming to eyes, and now I am able to perceive this pen, that okay, this is the pen that is kept here. Okay, some, it is not like that 100% of light that is coming on this pen will be reflected, because it is not a perfect reflector. So some part will be get transmitted, some part will be get absorbed. Okay, so all these things will be happening. So we this is the way how we used to perceive anything. Okay, this is about the representation, how light is represented. See, I have told you, let's suppose there is an object, okay, and here you are the observer, and here is the light source. What is happening? What is the complete scenario? How you got to know that, okay, this is an object that is kept here. Light source is there. Ray will be coming from the light source. It is falling on the object, and now light will be reflected back. The light that is reflected and coming to our eyes, and that ray of light will be helping us to perceive that, okay, to understand that, to visualize that, okay, here is an object that is kept. Okay. Same way here it is also represented. So we can see objects by two ways, basically by two ways. First is due to reflection of light, the first thing that we have already discussed. There is one more way. If the radiation of the luminous heated object lives in visible region, the rays that are coming out of the luminous object, the light source that is coming, that is present there, if that light source is radiating some waves, it is radiating some waves, and if that waves are lying in the visible range, then also we can perceive any object, or we can see what kind of object is there. Okay, sorry. See, now we'll enter into the properties of light. Some basic properties of light are there. One of the most basic and one of the most important properties of light that I will now tell you. If the light is changing its medium, let's suppose this is my hand, is the you can say it is a parameter. Okay, this is the surface I have taken. इसके ऊपर air है, and below this there is, let's suppose, some any other medium, water is kept. Okay, so if light is coming here, what will be happening? Some part of the light will get reflected. All of you know about the law of reflection, and some part of the light will be going under it. That is called as refraction. That is called as refraction. See, everything will be changing. If velocity of light in air is different, velocity of light in medium is different, wavelength will also be changing. But one thing is always same, that is frequency. Always remember, either it is reflection, either it is refraction. Frequency of light never changes. Wavelength will be changing, velocity will be changing. How that will be changing, that will also see when we'll be starting the reflection case. But as of now, understand that it will be changing. So the phenomena of light to come into the same medium is defined as reflection, and the phenomena of light to bend its path in and go into the other medium, this is basically defined as what? Refraction. So this is exactly what here it is explained. Let's suppose a light is coming and it is medium 1. Okay, here it is the incident and here is the source. And see, notice here, what is the, here it is written as, it is the velocity, here it is represented for frequency, and lambda is represented for wavelength. This light is incident on the surface. This is the surface of parameter that I have shown you here. Some part of the light क्या हो रहा है? Reflect हो रहा है. If it is reflecting, that means all the things will be same, because it is still in the same medium. But some part of the light is getting refracted. Some part of the light is getting refracted, and you can see that velocity is changing, that is v dash, wavelength is changing, that is lambda dash, but the frequency is still same. But the frequency is what? Still same. That means from here I can conclude that frequency never changes. Frequency never changes. Correct? So these are the two phenomena. One is reflection, one is refraction. Now first portion of this chapter, we are going to only understand about reflection. For reflection, what we used to do, we used to polish one side. That means we will be polishing one side, and one side only we will be working. Due to that, what will happen? All the lights that is incidenting either getting absorbed, either getting reflected. Nothing will be transmitted ahead of that, okay, due to polishing. See, now some basic terminologies that I hope that this is very basic. All of you would be knowing about it. Angle of incidence. What is the angle of incidence? One important thing that most of the students used to do mistake. Angle of incidence is always calculated from the normal. Please remember this. Don't make these kind of silly mistakes, that because now you are in standard 11th, 12th. Okay, you are preparing for such a competitive, and still I'm telling, I have checked a lot of students that they are making this basic mistake. They are calculating the angles from somewhere else, but the angles are always calculated from the normal only. See, so the angle of incidence, this is the incident ray. This is called as incident ray. This ray is called as incident ray, and this angle is called as angle of incidence. This ray is called as reflected ray, and this angle is called as angle of reflection. And if I will tell you what are the laws of reflection, laws of reflection says what? Angle of incidence is equals to angle of reflection. I hope that all of you would be knowing. What is the second law of reflection? That incident ray, reflected ray, and this is called as normal. Normal is what? Normal is, from the name itself, normal is very clear. Normal means what? It is normal, also called as perpendicular. Okay, so if you are drawing perpendicular to the plane mirror, that is called as what? Normal. Okay, so reflected ray, incident ray, and normal all lies on the same plane. This is the second law that we used to study. Okay, here it is given about the laws of reflection. These are the two laws that I have already told you. Now, interesting thing is about angle of deviation. What is angle of deviation? How much angle that it will be deviated? Okay, we'll be talking about the image formation from plane mirror also. Don't worry for that. So how the angle of deviation will be calculated? What is the angle of deviation? Firstly, let's understand. Deviation means watch the initial incident ray and watch the reflected ray. Okay, what is the change in deflection in the path that it was traveling? That is defined as what? Angle of deflection. That is defined as what? Angle of deflection. So if I will ask you, tell me what will the angle of deflection? See, here it is the incident ray coming. Okay, no problem. Here is the plane mirror. This side is polished side, and here it is reflected again on some angle, and I know that from the law of reflection, I is equals to R. That means I can say that this R is equals to I. So I can say what is the deviation? Originally this ray was propagating in this direction, propagate this ray, and now what is the change in path? What is the change in path that you will be commenting? Change in path, you will be saying, sir, this is the change in path, this is the bending in the path, and that bending is nothing but called as deviation, angle of deviation. And if I have to calculate it, how I will be calculating? If I'll ask you, tell me this complete angle, how much you will say, students? Kitna hoga ye angle? 180 degree, correct? That means pi is equals to, how much you will be saying? It is equals to I plus R plus of deviation. What you will be saying? I plus R plus of deviation. That means what you will be saying? Deviation can also be written as pi minus I minus of R. So it can also be written as pi minus of 2i. That can be called as, you can remember this as the formula of deviation, pi minus of 2i. 180 minus 2i. This is the in general formula for deviation. Clear? Deviation is an important formula that you have to remember, pi minus 2i. So here is a question, very good question. Okay, let's try to apply all the brain that we have in this question, and let's try to find the answer. Okay, मुझे ये बताओ, question is determine the net deviation after two reflections in the given scenario. Okay, there are only two reflections that are happening. And you have to tell, this is mirror 1, this is mirror 2. These are two mirrors from where two reflections are happening. Only two reflections. You have to tell me what is the net deviation. What you will be asking you about net deviation. So net deviation, can I write it as delta 1 plus delta 2? That means deviation from reflection 1 plus deviation from reflection 2. Simple. Now let's draw the ray diagram as well. Let's draw the ray diagram. कैसा होगा ray diagram? See, this is the incident ray, first incident ray. That means ray will be reflected from here. This will be going somewhat like this. And what will be this angle? Can you say this angle is also nothing but equals to 40 degree? Obvious thing. Now, if this angle is 40, this is the normal. I can say this angle is going to be nothing but 50 degree. If this angle is 50, and you will be drawing a normal at this plane also, correct now? because वहां पे भी तो नॉर्मल होगा. If this angle is 50 degree, tell me about this angle. Sum of a triangle. How much the sum of a triangle is? 60, 50 हो गया 110 and 110 minus of 180. That means this angle is going to be 70 degree. If this angle is 70, what you can comment down about this angle? That means I can say that this angle is nothing but going to be equals to 20 degree. Very obvious thing. And then it will be reflected again at 20 degree. Again it is going to reflect it at what angle? 20 degree. So now if I have to draw the deviation, how I will be drawing the deviation? Now let's understand how we can draw the deviation. See, here this was the original angle, this was the original angle, but now it is deviated, deviation that I am showing here is in which kind of rotation? I can say this rotation that I am showing you is in clockwise direction. That deviation is in clockwise direction. And here how much the deviation is coming? This was the original ray, and I can say this was the original path, but it is deviated in this way. Again, can you say it is the deviation 2, and this is deviation 1, and both the deviations that I am having, that is both are having in clockwise direction, correct? So if both are in clockwise direction, that means simply I can add up both of them. How much I will be writing deviation 1? बताओ deviation 1 कैसे लिखोगे? What is the formula? Pi minus of 2i. Pi minus of 2i. Pi is 180. That is 180 minus 2 of I. Angle of incidence is what? 40. That means it is 80. That is what you can say about angle of deviation 1. Can you say it is nothing but 100 degree? It is nothing but 100 degree. Okay. Deviation 2 कैसे लिखोगे? Deviation 2 again you will be writing 180 minus of 2i 2 times of. What is the angle of incidence? Can you say angle of incidence this time is nothing but 20 degree? That means 100 plus 180 minus of 40. That means I can write this as 140. That means it will be net equals to 240 degree. Clear? That means I can say the net deviation that I will be having, that is equals to 240 degree. And in which sense? It is in clockwise direction. 240 degree angle in clockwise direction. This is the net deviation that you will be clear. Now it's up to you. Anyways, you can remove the formula, but it is very obvious thing. Without removing the formula also, you can apply your basic knowledge and you can calculate the deviation. There is nothing such hard and fast rule. My voice is clear now. Once again, let me cross check. You can apply your basic knowledge and you can. Okay, yeah, it is very clear. Nice. I hope that this was clear. A lot of questions are coming like this way, and now I am going to tell you about a short trick. What is the short trick to calculate any kind of deviation that you will be having? कुछ नहीं करना है. Remember 3 steps. The mirror on which your light is incident. The mirror on which your light is incident, assume it as mirror 1 and close this mirror, and how much angle you will be taking for matching both these mirrors? 60 degree. Just double it. That will be your angle of incidence. Angle of deviation. You want to cross check it? What I've told. The mirror on which light is incident, assume it as mirror 1, and what is the angle between both these mirrors? Try to close this mirror so that you can have that this deviation is going to be clockwise or anti-clockwise. This kind of motion, that I can say that this is clockwise direction. Should we cross check it? Let's cross check it on our first question that we have solved. This one. What I have told you. This was your mirror 1. इसको बंद करना है. That means you will be taking this as mirror 1 and you will be taking this here. Correct ना? That means how much you will be taking? You will be taking this as 120 degree angle. But in which rotation? In which rotation? I can say this you will be taking in anti-clockwise direction. If you are writing 120 in anti-clockwise direction, that is also a correct answer. We have calculated 240 in clockwise. बात तो सेम ही है ना यार. 240 in clockwise, it is also equals to 120 in anti-clockwise. Sum of is always equals to 360 na. I hope that this is clear to you. So this is the short trick that you can apply in the questions. There is nothing very special about it. Let's apply this short trick in one more question. Where is the question gone? Determine the net deviation after 2 reflection. See, here light is incident somewhat like this. Okay, here light is incident somewhat like this. You will be assuming this as mirror 1. Assuming this as mirror 1, now you will be doing what? You will be closing both these mirrors. That means you will be doing this. What is this rotation, sense of rotation? I will say this is nothing but anti-clockwise direction. You are moving in anti-clockwise direction and double it. That means deviation that you will be writing, it is equal to 2 times of this angle. That means 80 degree. And in which sense? Anti-clockwise direction. If you want to quote the answer in clockwise direction, then it will be how much? 280 degree. That means it will be in a clockwise direction, it will be 280 degree. In anti-clockwise direction, the deviation is 80 degree. Simple. Okay, simple trick बता दिया, solve कर लेना. Any question you can apply it. Okay. See. The next case is rotation of mirror. Due to the rotation of mirror, what actually happens? The effect. अरे कहाँ गया? Rotation of mirror. अरे हाँ, fine. If you are rotating the mirror by an angle of theta, what will be the effect on the reflected ray? What will by what angle it will be changing? That is what we are going to calculate. Should we start? See, I am explaining you by different colors we have, so we have that liberty. We can explain you. See, this is the normal one. Okay, this is the angle of incidence 1 initially, and let's assume this will be what? This will be again I. This is the reflected ray. Let's name this as R1. Let's name this as R1. Now what I am doing, I am rotating this mirror by an angle of theta. I am rotating this mirror by an angle of what? Theta. Due to that, what will be happening? I will have now a new normal. I will have a new normal, and along with that, I will have a new reflected ray. I will have a new reflected ray that will be called as what? R2. Now I will be checking that by changing the mirror's angle by theta, how much the net change that is going to come into the mirror. Hello Shubneet. Okay, so see, if now it is the completely game of the angles. Okay, tell me how much this complete angle is going to come. This complete angle, this is the angle theta by which it have shifted. This is what you will be saying, I plus of theta. And what about this one? This one only, you will be saying, sir, this one is nothing but I minus theta. So if I will ask you, tell me what is the change in angle for the rays. Numericals कितने marks के आएंगे? In which exam? For which exam you are talking about? See, so what will be changing the rotation? Rotation you will be saying, sir, that will be I plus of theta minus of I minus of theta. Correct? Just that take the difference, you will be getting how much shift that is coming there. So I will get cancelled, and your ray will be shifted. Your reflected ray will be shifting by an angle of which exam you are talking about, Shubneet? Physics, which exam? JEE, NEET, KCET, boards, 12 boards, 10 boards. Which exam you are talking about? So whenever you change the angle of the mirror by an angle of theta, CBSE is used to always attach 12 boards. CBSE always attach with derivations, questions with derivations. So if there is a 5 marks question, if I am talking about CBSE boards, okay. So if there is a 5 marks questions, okay, so they will attach 2 marks with derivation or 3 marks with derivation, and then they will attach 2 marks of numericals. So this way you can expect these days the pattern. Last year it was a good numerical kind of paper. If you will check the paper last year, it was very good, decent level of the paper was, because some good numericals were there. So numericals are coming in weightage, so you have to be aware about that. So you should have the good practice of numericals as well. Okay, so you can expect nearly 25 to 30 marks it can be come from the numerical section. If it is a 70 marks paper, you can expect that much of the paper from the numericals. Okay. So fine, you have to remember what, that if the mirror is rotated by an angle of theta, your reflected ray will be changing, deviated by an angle of how much? 2 theta. Always remember this, and it is valid for omega relation also. If a mirror is rotating by an angular velocity of omega, your reflected ray will be moving with an angular velocity of 2 omega. It becomes always 2 times. This is a simple relation that you always have to remember. Now, what is the velocity of plane mirror? Velocity of image in plane mirrors. Velocity of image in plane mirrors. It is very obvious. Let's suppose here it is a mirror. Go in front of mirror and stand. What you will observing, the rate at which you are going close to the mirror, the image is also coming at the same rate towards you. That means if you are taking one step towards the mirror, the image is also going to take one step towards you. That means we define that velocity of object and velocity of image in a plane mirror is always same, but the only change that will be coming in terms of vectors, because we always define velocity in terms of vectors. That means just attach a negative sign along with that. For example, what I am saying, what I am trying to tell you, that if this is the object and it is, let's suppose, coming with some v0 velocity, this is the image that will be coming towards you, and it will also be same. The velocity of object will be same as the velocity of image, but only change will be, if this direction is positive, this direction will become only negative. Actual good questions comes from velocity of object or image with respect to mirror. When the question is asking you with respect to mirror kind of question, then actually it becomes a good question. So I will tell you a direct relation that you can follow for solving all these kind of questions. See, let's suppose there is an end, okay, kept on the mirror, okay, and this is the velocity of mirror. It is moving on this direction. This is the velocity of object, and now the question is asking you, tell me what is the velocity of image. What is the velocity of image? Okay, this is what the question is asking. Nothing with respect, not with respect to mirror. The question is simply asking you, tell me, if this is the object, this is the mirror, you just tell me what would be the velocity of image. That's it, what we have to calculate. So what I have told you, that velocity of object is always equals to the velocity of image, but only difference is what, there will be a negative sign, because the image direction is reversed. So if the question will be asking you velocity of object with respect to mirror, then also you will be writing what, minus of velocity of image also with respect to mirror. With respect to mirror, what, stopping the mirror. With respect to mirror means what, stopping the mirror. Okay, now see here, how you will be writing velocity of object with respect to mirror. You will be writing velocity of object minus of velocity of mirror, correct, minus this much of relative velocity. I hope that you will be understanding. How you will be writing velocity of image with respect to mirror. You will be writing velocity of image minus of velocity of mirror, Now this minus sign will be going inside, and what you will be getting, you will be having velocity of image is equals to 2 times of velocity of mirror minus of velocity of object. Velocity of image is equals to 2 times of velocity of mirror minus of velocity of object. Double kar do velocity mirror ka, and then subtract the velocity of object. That is what, that's it. This is going to give you the final result. Let's see if it is working or not. Here is the question. Let's calculate how much the velocity of image will be coming. Solve karo. What the question is asking you, the velocity of image. Velocity of image, just we have seen, it is equals to 2 times kar do velocity of the image of the mirror minus of velocity of the object. Let's do it. Velocity of mirror, what you'll be saying, minus of, why I am writing minus, that is also important, because it is moving negative direction, and conventionally we always take minus negative direction as, or this direction as negative direction. Minus of velocity of object is plus of 2. That means what you will be saying, minus of 10 plus of 2. That means answer that you will be quoting, that is equals to, sorry, here it is not plus, here it is minus of 12 meter per second. That means image is coming towards the mirror in the negative x-axis, or I can also write it as minus of 12 I cap meter per second. This is showing you the direction as well. This will be the direct velocity of the image. Correct. Same way you can solve this question also. There is one more question for you for practice purpose. This time the velocity of mirror will be taken as positive. That's it. That is the only change, and you can solve it. It will be a homework question for you. Now let's discuss about the image formation by plane mirror. We have seen a lot of things about plane mirror, but we have not talked about that. Okay sir, fine, we have seen everything, but how images are formed? What is the actual ray diagram that we have to understand for the formation of image in a plane mirror? Okay, so let's discuss that also. See, this kind of something is happening in your plane mirror. This side is called as reflecting side, and I've told you now already that one side, what we used to do, we used to polish that side. We used to polish that side so that not any light can be moved on the other side of the mirror. Okay, so one side is polished, so whatever the light that is incidenting here, this is the incident beam and this is the reflected beam. And already you know the relation between angle of incidence and the angle of reflection, that if angle of incidence is always equals to angle of reflection, and if parallel rays are coming, incident rays are parallel, that means reflected rays are also going to be parallel. Clear? Now see how images are formed. Let's suppose there is a plane mirror. This is the scenario. Okay, let's suppose here is your object is kept, here is your object is kept, and I will assume, and let's suppose it is kept at some distance d from the mirror. It is kept at some distance d from the mirror. So what I will say, let's suppose for forming any kind of image, this much of basic thing you would be knowing. For forming any kind of basic image, you require at least two rays, two light rays. It is minimum requirement, and the converging point of two rays is called as what? Is called as what? It is called as the image. What is the definition of image and object? That is also important. The intersection point of two reflected rays is called as what? Image point. And the point where two incident rays are converging, that is called as point of object. Sometimes it is real, sometimes it is virtual. If it is actually intersecting at a point, if it is actually meeting at a point, that kind of point is called as real image or real object. If it is virtual or it is just appear, it is not actually. I will tell you by the cases that we are going to understand, because like this only, plane mirror always forms a virtual image. Okay, why we say that it is always forming a virtual image? Reason is there. See, a simple trick also you have to remember. If the in reflection case, if image and object are on the same side of the mirror, then it is called as real object, real image. If the object and the image are on the other side, then it is called as real image, virtual real object, virtual image. Is this clear? And vice versa in reflection case. In reflection case, if object and image are in the same side, if object is real, image will be called as virtual if it is on the same side, because reflection forms always the image on the other side. So if it is actually, because on the same side, it is not possible to actually converge. Okay, so how we decide in plane mirror, I will tell you about the cross section diagram. See, let's suppose one ray is directly coming like this, perpendicular to the mirror, and it will be reflected back on the same line. Second, let's suppose it is coming at some angle and it is making some angle and it is reflected like this. So this is the one ray, this is the second ray. This is the way they are going to propagate. Can you tell me at what point they are going to converge? Never. They are never going to be converged if you are taking on the same side. But if you are extending these rays, then they will be appear to converge at a point, and that appearing to converge at a point is called as what? Image. And that's why I have told you also that these points are not actually converging. These points are just appear to getting converged at a point, and that point is called as what kind of image you will be having? You will be having virtual image. Why you are having a virtual image? Because the rays are not actually converging, they are just getting appear to converge. They are just getting appear to converge. Clear? So if I can say, if this distance is d, what you can say about this distance? This is also going to be d. This is the property of plane mirror. This is the behavior how you can form a image by a plane mirror. I hope that this is clear to you. So here you can understand by always you have to take two rays. Always you have to take two rays. One important point is what? That distance of image is equals to distance of object from the plane mirror. Is it clear? Rest of the points, I hope that it is clear. The definitions are all given here. What is image? Image is a point of intersection of reflected. What is object? Point of intersection of the incident rays. Normality, plane mirror is perpendicular bisector of the, what we define normality, that plane mirror is always perpendicular bisector. Perpendicular bisector, first thing is perpendicular, that means it will, if you are bisecting, that means perpendicular bisector means what, if this distance is d, this distance is also d, equally it is bisecting the distance between object and image in two equal halves. So these are some basic definitions. This kind of regular reflection that is in our portion, majority of the times this kind of reflections we are going to understand. This is called as regular reflection. If the, it is not a smooth surface, it is having a lot of curvical kind of surfaces, that means of course the radiuses, the reflected rays will be at different angles. If the, even if the incident rays are parallel, due to this angle, normal will be changing at every single point. If normal will be changing, according to that, what will be happening, angle of reflection will also be changing. So what I can say here, this kind of reflection is called as diffuse reflection. Okay, only the terminology that you have to understand. Now here it is an interesting question. What the question is telling you about, see, a plane mirror is inclined at 30-degree angle. A plane mirror is at some 30-degree angle from the horizontal as shown. Okay, it is a very important conceptual question. Object is placed on the x-axis. There is an object that is placed on the x-axis at a distance 2 meters from the origin. That means this object coordinates, if I'll ask you, this is 2, 0. This is what, 2, 0. Find the coordinates of the image formed. Find the coordinates of the image that is going to be formed. Find the coordinates of image. How the image will be forming? How the image will be forming? I've told you just in the last slide that plane mirror act as a perpendicular bisector between the distance of object and the image. It acts as what? Perpendicular bisector. So here also it is going to behave like a perpendicular bisector. So firstly, let's calculate what is going to be this distance. Let's suppose if this distance is going to be d, what I can say about, can I say here somewhere your image will be forming, and I can say the coordinates will be, let's suppose, x and y. What will be the coordinates? X and y, correct? Because it is a perpendicular bisector, if this distance is d, what I can say about this one is also d. Clear? Now I can connect this point and I can say all the things are going to be symmetrical. If this angle, I can say that this is anyways going to be perpendicular. If this angle is 30 degree, this angle is also going to be 30 degree. Now, how you will be writing these coordinates? How you will be writing these coordinates? That is an interesting thing. Okay. So how you can write? See, can you calculate this distance d? Can you calculate this distance c? Are you able to calculate this distance? See, this is the triangle AB. Let's suppose this point is C. How you can calculate? This angle is going to be perpendicular. This is the hypotenuse that you already know, and what you have to calculate, the define sine of theta into this triangle. Define sine of theta. What you will be writing? Sine of 30 degree. Sine of 30 degree means what? Half is equals to perpendicular. Perpendicular is d divided by the base. What is the base that you will be saying? Perpendicular upon hypotenuse. Sorry, perpendicular, and this is the hypotenuse, that is 2. That means what you can say about d? D is equals to what? 1 meter. That means this d is equals to how much? This d is equals to 1 meter. And if this d is equals to 1 meter, what you can say about this one? This can be also written as 1 meter. That means this complete distance is going to be how much? Can you say it is nothing but going to be equals to, again, 1 meter. Is it clear to you? Is it clear? So if I'll ask you, if this angle is 30, this angle is so can you tell me about this angle also? Let's calculate about this also. This is 90, this is 30. That means this angle will be equals to how much? 60 degree, correct? So now let's calculate this. What you can do? This position x, this angle is 60, this angle is 60. That means this point is also 60. You have to find the reflection of this point. So if you are taking this point coordinates, you can write x cos of theta. What you will be defining? X cos of theta. X cos of 60 degree is equals to how much? X cos of 60 degree is equals to, you can say it is going to be equals to 2. So if you are taking the x component or y component, so it will be x cos of 60, that is equals to root and half. Wait a minute, I'm doing somewhere the mistake. See, this distance is equals to 2 meter. So when you are taking this, correct, this can be written as 2 cos of 60, that we were writing correct. This distance is 2. Here this angle is completely 60 degrees. So what you will be writing? So you will be writing this point as 2 cos of 60, and here it will be writing as 2 sin of 60. Now what is 2 cos of 60? We have already calculated the angles. Okay, we have already calculated the angles. Now we just have to take the components. So this coordinate, this x coordinate and y coordinate are here. This will be written as x cos of 60 degree, and this point will be written as 2, because this distance is 2. This will be written as 2 sine of 60. 2 cos of 60 means what? 2 root under 3 by 2, and here it will be written as 2 into half. This will be cancelled, and here it will be written, sorry, this is half and this is root by 2. That means this is 1 and this is root 3. These are the points that you will be having as the coordinates of your image. These are the points that you are going to have as the coordinates of the image. Clear? Now next question, very interesting question that again you will be having. Good that you are learning. Next very interesting question that you will be having: what is the time that will be reflected into the watch? Okay, there is a trick that I will tell you. What you have to do. See, this is the time that is reflected here. What is the time that is actually there? Actual time is 4:25 minutes, 4 hours 25 minutes and 45 seconds. This is the time that you are actually having. So the question will always be asking you, tell me what is the reflection of this time that you will be watching in the mirror. So if you are having the reflection, the trick is always you have to make this summation of the actual time and the time that you are having into the plane mirror. The sum should always be equals to 12. That sum is all should be always equals to how much? 12. So how you can make the sum 12? See, for making 12, how much hours you should remaining? It will be 7 hours 34 minutes, and here it is 15 seconds. If you are adding both of these, check. 15 plus 45, it is going to be 1. Here it will be 0 0. 34 plus 25, it is going to be 59. Again carry was 1, that means it is again going to be 0 0. And 7 plus 4 11, and it will make it 12. So the answer will be what? 7 hours of 34 minutes and 15 seconds. In this way, you if any this kind of question it is coming, the summation will always be 12. Okay. Now the next kind of question that you will be having is from field of view. What is field of view? Field of view, I have told you about the image formation, how image is formed in a plane mirror. In case of plane mirror, how image is formed. So let's suppose why it is a requirement of field of view. Let's suppose if the length of the mirror, that if we are shortening that, then it is the case that the questions can be asked, what will be the range that will be present so that you can watch the image of the object that you are having. So these kind of scenarios are generated only in the cases of small mirror, small length of mirrors, it will be happening. Okay, see, what is field of view? Let's suppose this is your object. I've told you already about the how the image is going to be formed. This is the way. Let's suppose lights are getting reflected, and of course if this is angle θ1, this will be reflected like this. This is going to be reflected like this, and this is the point that will be forming your image. Field of view, some basic steps that you have to understand. What are those basic steps? Draw the light rays that are coming from the image. Draw two light rays that are coming from the image and pass it from the extreme points of the mirror. What are the extreme points here? Let's suppose this point is A, this point is B. Pass these two rays from the extreme points. One extreme point is A, second extreme point is B, and whatever the area that is swept after this mirror, that complete area is called as field of view. That means what I am trying to say, if you are watching from here, if you are observer, you are watching from here, that means you will be able to watch this image that is present from the mirror. But in case if you are watching from here, then also you will be able to perceive this image that you will be having. But if your image is here, if you are watching from here, then you will not be able to watch the image of the object in the plane mirror, because you are out of the field of view. You are out of the field of view. So what kind of questions we actually create? Let's understand this by a question only. Okay, steps I have already told you. Here, let's suppose you have to draw the field of view. How you will be drawing? Firstly, you will be finding your image. If this is the object, of course at some same distance d, you will be having your image also. You will be having your image also. So this is the position of image. Now draw the rays that are coming to the two extreme points. This is the one extreme point, this is the second extreme point. This complete area that is coming, this complete area is called as field of view. If your eyes are in this region, you will be able to easily perceive this, the image of the object that is present there. Okay, yeah, this class is completely, here we are actually discussing the complete thing, complete derivation part also. Okay, so we are going from the complete basic, from the complete scratch level to the mains level also. So we are covering all the varieties, trying to cover, and then we'll be having a question series, so that you can have a very good practice along with us. Okay, so here your all the concepts will be clear from the basis. So let's understand what kind of actually questions are coming from the field of view. Read this question, and from this question only I am going to explain you. You have to understand some of the basic things will be required, like what are the congruent triangles, what are the property of similar triangles. That is what we have to understand. Let's understand this question. Find the length of the path for which the observer moving as shown could view the image of the object O. See, some important points are given. Here it is represented, a boy is there and he is having this kind of path. Okay, he is having this kind of path, and here is our object. Here is our object. The question is asking you what will be the length that this boy will be traveling, so that he can watch the image that is of the object. Okay. So in all these kind of questions, then they will be asking you about the either the length of the mirror, what is the minimum length of the mirror required. Either if they are asking you about, if the question yeah, of course, I hope that this will be asked, clearing your doubts. It will be, I have discussed all about the plane mirror concept. So if the boy if the question is asking you about the length of the mirror, either it is asking you about this kind of question. So all in this case we have to make firstly the field of view. Okay, tell me in what range if I will be present, in what range my eyes will be present, so that I can watch the at least the image of my object. So let's firstly draw the ray diagram. See, if this distance object distance of object is d, what will be the distance of image? That will also be d. And how we draw field of view, I have told you. Locate your image and draw the rays coming out of there to the two extreme points. One extreme point is this, let's name this as A, and the second extreme point is the lower end. Let's suppose the name is B. So draw the rays that are coming out from here and pass it like this. Second extreme, let's pass it like this. That means I can say, if you are this is the observer, this is the complete distance that if you are present in this range, let's suppose you are walking in this range, if you are in this complete range, and this distance I have given you as 2x, if you are present in this 2x of the length, then you will be able to watch the image of this object as clear as that. Okay, now for solving purpose we always take two triangles. Focus on these two triangles. This is the bigger triangle, the distance that I have taken, and this is the smaller triangle. This length is L, that means this length will be L by 2. And I will be naming some points also. This point is A, I, let's name this as B, this name as C, this as D. I will be saying what? Understand our basic, if you remember the similarity of triangles in the basic classes that you have studied. Triangle CDI is similar to triangle ABI. And from the similarity of triangles, we used to say the ratio of the sides is always also equal. The ratio of the sides. So I will say this complete bigger triangle to this smaller triangle, we can make the ratios of the sides equal. How will we be making this ratio? See, the smaller triangle, this distance is how much? L by 2. L by 2. Same ratio I will be taking for the bigger side. How much this bigger side is for this distance? How much you will be saying? This will be x, this will be what, x is equals to, for the smaller triangle, what is this distance? Tell me. This distance is nothing but d. For smaller triangle, it is d. What is that side for the bigger triangle? What is this bigger triangle side? This distance a can be written as 2d, and this distance is d. That means total distance is 3d. Total distance is 3d. Now see what you can do. This d will simply get cancelled. Here what will be gained? L by 2x is equals to 1 by 3. That means what you can say, 2x is equals to 3l. And exactly can I say that is what I wanted to have. I have named this distance. I didn't know about it. It was equals to 2x, I have assumed. And finally my answer is coming, that is equals to 3l. And what is the length of the mirror? That is l. So if what is the range in which if I am walking so that I can perceive the image, that is equals to, just do 3 times the length of the mirror, you will be having the complete view for this image of the object. Is it clear? First step is what? You will be drawing field of view, then you will be applying geometry. By applying geometry, you will be watching the similarity of the triangles, and then you will be solving about it. Okay, just make the sides ratio equals. Here it is also, and the notes will be available for you. Okay, now the last portion from where some questions are coming. That tell me, what is the number of images? Number of images, very simple way. There is a term, just always define. There will be 2 mirrors that are bent to each other. Mirror 1 and mirror 2. Both are bent to each other, and let's suppose the angle between them is equals to theta. The angle between them is theta. So we define a term 360 divided by theta. We define a term 360 divided by theta, and we name it as, let's suppose, n. And number of images have direct formulas that you can apply and have your answers. What is the answer? If this n is coming as even integer, if this n is coming as even integer, then number of images that will be formed by this 2 mirrors that are bent on each other is equals to even same number n. For example, let's suppose, it will be minus 1. It will be minus 1. Let's suppose this theta is equals to 60 degree. If this theta is equals to 60 degree, that means what you will be getting? 360 divided by theta. 360 divided by theta, you will be getting 360 divided by 60. That is equals to 6. That is equals to 6. N is equals to 6. So if the question is asking you, tell me what is the number of images that you will be having, number of images will become n minus 1. That is equals to 6 minus 1. That means answer will be what? You will be having 5 images. You will be having how much images? 5 images. Is it clear? Now let's see the different case. Let's see. Let's take some different case. Tell me a number where you can have some odd multiple. Do you have any idea of any angle? Tell me in the comment section. कौन सा angle लोगे कि you can do 72. हाँ, correct. I think you can have 72. Let's suppose theta is given as 72 degree. Let's suppose theta is given as 72 degree. Now it will have, what you will be doing? You will be having 360 minus theta. Always we define as 360 divided by 72. 7 5 ja 70 into 5, 350, and 2 into 5 times. That means it will become 360. Correct? That means I can say in 5 times it is going. Now 5 is not an even number. So what about the case of odd number? If n is coming equals to 5, now you will have 2 cases. If it is symmetric or if it is unsymmetric. Now what is the meaning of this symmetric and unsymmetric? Let's suppose this was the angle which was bent, and this angle was equals to 72 degree. If your object is lying at the angle bisector means exactly 36 from here, exactly 36 from here. If this object is lying on the angle bisector, this kind of thing is called as what? Symmetric. But if it is lying either down one side or either upward side, then it is called as unsymmetric. So if it is a symmetric case, then again it will become n minus 6. That means it will become 5 minus 1. That is equals to number of images will be equals to how much? You will be quoting as answer 4. But if it is not placed on the angle bisector, then you will be calling this as, okay sir, number of images will be directly equals to 5. Number of images will be directly equals to 5. Okay. So this was the last portion of plane mirror. We have covered complete basics of plane mirror in this lecture. From the next class, we are going to start reflection on the spherical surfaces. mirror formula, derivation of mirror formula. From all these things we are going to understand magnification, velocity also in spherical mirror. So all these things we are going to understand from the next lecture. Until next time, keep learning, keep growing with Tapasya. Endigu, Endendigu, Nama Tapasya.